Hey guys, so obviously I'm not sitting in the room with you right now, but I wanted to be able to still just kind of have you listen to me as I go through the notes. This is a review. You talked about quadratic functions in Algebra 1, and we talked about some quadratic functions in Algebra 2 during the first semester. We talked about factoring and how to find the zeros. We talked about standard form. We talked about a good bit of stuff with quadratics, but we're going to get into it. Going to detail so that we can kind of go into some word problems with them. The same way we were working word problems with linears and exponentials a little bit earlier. So we're just going to kind of do a quick review. In this dotted box, a quadratic function is a function that can be described by the equation in the form. Well, we learned standard form looks like this. ax squared plus bx plus c. And we, for standard form, had it set equal to 0. For our purposes right now, we really don't necessarily need to have it set equal to 0. In fact, we're actually going to, it'll help us later if we go ahead and set it equal to y. So we'll come back to that equation in a little bit. But let's kind of start going through these problems. And again, these are all a review. The highest exponent is, well, we know that the highest exponent is specifically called the degree. Anytime you're looking at a quadratic, what actually makes it a quadratic is that it has a degree of 2. So the highest exponent is always going to be 2. And again, we remember that we call this the degree. If you see the degree being 2, so you see the highest exponent throughout the whole thing being 2, that is a quadratic. It might not have a c, it might not have a bx, it might not have an a. If you see x squared, it's quadratic. The coefficient of the squared term cannot be a decimal or a fraction. As far as it has to be, it cannot be equal to these. Okay? Meaning our a value cannot be between 0 or equal to 0 and 1. It needs to either be less than 0, meaning a negative number, or it needs to be greater than 1. The graph looks like a, see if you can think about this. When I have a quadratic and a graph, what does it look like? It looks like a U. It can be a right side up U. It can be a downward U. What do we call this type of graph when we've got a U shape, that kind of hill or that mountain shape? We call it a parabola. You know this, okay? Parabola looks like a bowl. The parabola faces blank if a is greater than 0. So this would be something like if we had 3x squared plus something plus something, okay? Where this number right in here is greater than 0. Well, if it's greater than 0, parabola is going to face up. Okay? Both ends show that we're going up. We're greater than 0. Likewise, the parabola faces blank if a is less than 0. Well, if a is greater than 0, it goes up. It would go down for a less than 0. Looks like a frowny face. Something with a less than 0, that'd be something like if I had negative 2x. Okay, so pretty much if you've got a positive, it's going to be an upward facing U. If you've got a negative, it's going to be a downward facing U. Pretty simple. Let's see if you can remember this. It's been quite a long time. Quadratic function can have 0, 1, or 2 blank. Well, for this blank, we're really trying to think of where it hits the x-axis. It can have 0, 1, or 2. We've got multiple names. It can be roots. It can be zeros. It can be solutions. Or it can be x intercepts, okay? We use all those words interchangeably, so really you need slashes instead of commas, my bad. Okay? Any of those things are correct vocabulary. You'll tend to hear at least me call them roots or zeros. Okay, I don't tend to use the word solution or x-intercepts, but roots and zeros, typically what I have on my tests or quizzes and what I say in class. All it means is this is where the x-axis crosses. This is when you factor and you find those x values. This is what you're finding. The lowest or highest point. We call this the vertex of the parabola. If it's a low point, that would be a minimum. Likewise, a high point would be a maximum. And these sometimes might get you a little confused as far as which one's which, just because if A is positive, meaning greater than 0, then we have that upward facing view, okay, like we see up here. That is when we have a minimum. Some people think, oh, it's going up, I have a maximum. No, you don't. You have a place where your view dips down and then changes direction. That's a minimum. Whereas a maximum would be when my A is less than 0 and I've got it facing down. Parabola goes up, it hits its maximum, and then it turns and goes back down. This last one might be a little bit new to some of you, so I'll just go ahead and fill it in. There is going to be a vertical line that goes through the vertex, okay? So I will show you what it kind of looks like on the next slide. Okay, but I've got my parabola. My vertex is either at my minimum or maximum. And then there's going to be a vertical line that goes straight through that vertex. And we call this line the axis of symmetry. Take a second and think about what symmetry actually means. What this line does is it is a line that goes straight through the center of the parabola that shows the mirror image. Okay, so if I was looking at the left side and trying to create the right side, I could take the left side and flip it over the axis of symmetry, and the right side is the exact same thing. Okay, it's that line of reflection. So let's kind of move on to actually identifying things within parabolas and kind of looking at where everything is and what it looks like when you've got an A positive and an A negative. So on this last, or in this next slide, I'm sorry, not last, but on the next slide, first off, I'm going to add one arrow. So if you can add this arrow to your sheet also, I want to add an arrow right there. And let's start going in and filling things in on our page. So the first thing I want to look at is I want to look at this equation, okay? This equation right here. I want to think about what my A is, what my B is, what my C is. Okay, and we're going to start kind of making connections. So my A is always the coefficient that is sitting with x squared. And specifically, I want to say, is that going to be a positive number? Is it going to be a negative number? So I look at this equation, I see just x squared. I don't see an A value sitting in front of it. When I don't see a coefficient, we know that coefficient is positive 1. Okay. So my A being positive 1, that's a greater number than 0. That's a positive number. That is why my parabola is facing up right now. Just to work on identifying, my B would be negative 2. It's the coefficient in front of x. And then my C is my final number, my constant. Sorry for all the equal signs. Okay. And that's going to tell us something specific about our graph. So we're going to kind of go through, we're going to fill in all these arrows before we actually talk about that. But C tells us something specific about our graph. So I'm just going to go around and we're going to start actually filling in all these arrows. So this first arrow is a dotted line, and it connects to this dotted line right there. Okay, so I need to think about what that dotted line is? Well, it goes straight through the vertex. This dotted line represents my axis of symmetry, which we can call AOS, just for short. The next set of lines that I'm looking at are these right there, okay? They're pointing at the two places where this parabola crosses through the x-axis. So what could I call those? What would those be called? What do we call the areas where a graph passes through the x-axis? You should be saying x-intercept. We don't really call these x-intercepts so much. You can, okay? But typically when we're talking about quadratics, we call them roots, solutions, something in that realm, okay? Moving downward, I'm now looking at this arrow right here. So this arrow is pointing to what I see as the minimum of this quadratic. So what do we call that? We call it a vertex. Okay, the vertex is the point at which a parabola changes direction, either maximum or minimum. In our case, we do have a minimum. Keep in mind from our first page that when our parabola is facing up, we will have a minimum. When it's facing down, we will have a maximum. And then the final area is the one that I drew specifically. So you can see my arrow is going to where my parabola is hitting the y-axis. So we would call this our y-intercept. I want to go through really quick, and I just want to actually identify for this graph specifically where these things are. So going back up to the axis of symmetry. The axis of symmetry is a line, which means when I write the equation for a line, it's either going to be x equals or y equals. In our case, this is a vertical line. Vertical lines will always have the equation x equals blank. And that blank represents where on the x-axis that line is going. So I'm going to have x equals, well, if I were to follow this line, it's going to hit at x equals positive 1. So when I'm writing the equation, it would be x equals positive 1. My roots and solutions, those are x-intercepts, so they also would be x equals. And because I have two, I'm going to write it two separate ones. So I've got one right here. I've got one right there. Where are those on the x-axis? What x value are they sitting at? Sorry. Man, we're all over the place. One is at -1, and the other you should have gotten is at 3. So we've got two roots, one at -1, one at positive 3. The vertex is a coordinate point. When we write this, it's an actual coordinate point, meaning it's got two sets of parentheses, a comma, and an x value and a y value. So let's go ahead and get those ready. At what x value is this coordinate point? We're looking right here, this vertex. You should be saying that it's at 1. Now, what y value? You should be saying -4. So with that, I've got the coordinate point for my vertex, and the last thing I have to do is my y-intercept. The same way that the x-intercepts, or the roots, were x equals blank, because they were touching the x-axis, the y-intercepts would be y equals blank, because they're touching the y-axis. So where on this graph, here's what I'm looking at. Where is that on the y-axis? At what measure, okay, at what interval did we cross the y-axis? You should be saying positive 3. So we've got everything filled in. We just got to come in and fill in this box. The vertex is a blank because a is greater than 0. We already kind of answered it. We just put it in a different spot. It is a minimum. Okay. this is always going to be true. If our a is greater than 0, we are going to be working with a minimum. Now, there is the exact same problem, just with a different looking parabola. Make sure that you are adding that arrow for where we cross the x-axis. You go ahead and fill in everything we did. Fill in where the vertex is, okay, and what the coordinate point is. Fill in where the axis of symmetry is and what the equation is, where the roots are and what their values are, their x equal values, and where the, I believe the the y-intercept is as well, and then fill in the box. Well, our last box, if vertex is a minimum, if a is positive or is greater than 0. So this bottom one is a is less than 0. Well, what's the opposite of minimum? A maximum. So real quick, pause this video, you go through, you fill in everything, and then come right back and see if you got the right answers. All right, so hopefully you have already done this and you're already seeing that your names match mine. Now I just want to point out a little connection, because I didn't point it on the last one. Take a look at our axis of symmetry. X equals -1. Take a look at our vertex, and specifically the x value of our vertex. What do you see? You should be saying, hey, they match. That's always going to happen. Once you find the x value of your vertex, it is going to match your axis of symmetry. Because your axis of symmetry goes through your vertex, so it's in the same spot. And because we're only looking at the x value, that's why it's matching the x and not the y. Okay. So if you ever come up with a problem where those two things don't match, you need to go back and kind of check it out again and see what's going on. So let's talk about how to find the vertex if we don't have this graph. Finding the vertex on the graph is not hard. You're going to either the maximum or the minimum. You're finding the coordinate point. But when I'm giving you an equation, you're not going to go through and graph every single equation I give you, every single parabola, and then go find the vertex. There's a shortcut. There's another way. So we've got step-by-step instructions that we've written out for how to find your vertex. The first step is going to be identify A and B. Okay, we're not worried about C. We don't care about C. We only want A and B. So I would go through and identify A and B for all 4 of these problems. If you want to kind of go ahead, jump forward and do that, that'd be fine. I'm going to do them individually just because I'm going to go through only a couple of them. And then let you kind of go off on your own, and I'll provide the answers so that you can make sure that you get them right. But if you want to go ahead, take a second, do that, pause the video, and go through and identify A and B, that's fine. Remember that A is the coefficient in front of x squared, B is the coefficient in front of x, and they'll keep the signs that are in front of them as well. So once I've identified A and B, I'm going to plug A and B into the vertex formula, which is given to you right here. Okay, this is only for the x value of our ordered pair. Okay, we're going to have to do something more to find the y value, but for the x value, we would take the opposite of b. Don't necessarily think negative b, okay, because I get a lot of students who say, oh, b is already -4, so I don't need to do anything there. No. Whatever b is, -4, +4, whatever, take the opposite of that, and that's what goes in your numerator. Then you're going to divide by 2 times whatever a is. The denominator can be negative, that's fine, it might happen sometimes. Okay, so don't freak out if that happens. Go through itself, go find a single number. Okay. Once you find that single number, that is your x value. We move on to step 3. Step 3 says plug that x value you just got into the quadratic equation, okay, the quadratic equation you got, the original problem, in order to find the y value. That's why we set the quadratic function equal to y in the beginning of the notes, just so we can kind of come back to that. Okay. So once we found our x, y value, we move on to step 4. Set up the ordered pair, x comma y. There's your vertex. not too bad. We're going to go through, we're going to do a couple problems, and I'm going to give you the answers and let you do the rest of the problems on your own. So if you want to go ahead, take a second, identify A and B, and then kind of come back to me. For the first one, okay, I'm going to go ahead and actually write out a good bit of stuff for the first one just to really make sure that we're keeping on track. So for step one, I specifically want to identify what is A and what is B. Well, keep in mind, A is dealing with this first term right here. It's the coefficient that's in front of x squared. So what coefficient do you see in front of x squared? You should be saying nothing because there's nothing there. Well, when there is nothing there, we assume that that coefficient is going to be positive 1. Okay, if there was a negative there, it would be negative 1. Likewise, with B, we are looking at the second term, and notice that I circle the sign that is in front of the second term. Okay, that sign is going to be included. So here, our B would be positive 4. So we should be good on step 1. Step 2. This is where we're plugging into the vertex formula. Specifically, we're getting the x value. Okay. So we have negative b over 2a. Well, b is 4, and that negative tells me to do the opposite of 4. So the opposite of 4 is negative 4. 2 times a. We said a was 1. What is 2 times 1? 2. What is negative 4 divided by 2? Negative 2. So the x value in my ordered pair is going to end up being negative 2. But I'm not quite ready to write that ordered pair yet. I still need to go through with step 3, and I need to find the y value. In order to find the y value, I am going to take the original equation, which was right here, and I'm going to use that original equation. I'm going to plug in my x value anywhere I see x. I'm going to substitute. Okay, so my first term is x squared, so I would have, let's get back into black. I'm going to have negative 2 squared. Then I've got plus 4x, so plus 4 times negative 2. Then plus 3. Now, it is very, 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 very important that you make sure that when you have a negative x value, not if there's a negative in the equation, but if you have a negative x value, it needs to be inside of parentheses. Okay, if you are planning on plugging this straight into the calculator, it needs to be inside of a set of parentheses. Your calculator will give you the wrong answer if not. I'm going to just go through and do it in my head because this is pretty simple math. Negative 2 squared, that's negative 2 times negative 2, which I know is 4. Then 4 times negative 2, well, that's negative 8. So I've got a minus 8. Then I've got that plus 3 kind of tagging along. Right, well, 4 minus 8 is negative 4. And negative 4 plus 3 is negative 1. So I have found the y value of my vertex. Now I've got the x value, I've got the y value. I am moving on to my final step. Step 4 is to create the ordered pair. X value is negative 2. Y value is negative 1. Here is my final answer. There's my ordered pair. That's what I've been looking for. So this will go a little bit quicker as you are kind of getting more comfortable with this. So I wouldn't think that you're going to have to write out every single thing that I did. It's just since it's the first problem, I wanted to make sure that we were really, really on track with everything we were doing. Okay. So over here on the second problem, I'm not going to write out step by step. I'm going to look at the problem, and I'm going to identify my A and B first. So hopefully you said your A was 2 and your B was negative 4. Then I'm going to come in with that vertex formula, negative B or opposite B over 2A. Well, my B is negative 4. So I need to take the opposite of that. The opposite of -4 is +4 times 2a. Well, 2 times a is 2, so 2 times 2, that's 4. What is 4 over 4? What's anything divided by itself? 1. Now for my y value. Y equals 2 times x, so I get to fill in my 1, squared, minus 4 times x, get to fill in my 1 again, minus 2. Now be careful, okay? When you are doing this, we are going by orders of operations. Yes, order of operations says you start with parentheses. What that means is if I had something like 3 plus 4 inside of a set of parentheses, I would need to work that out first. It's about evaluating your parentheses. I don't have anything inside of parentheses to be evaluated, so I get to skip straight to, exponentials. The only exponent I have is right here, 1 squared. What is 1 squared? Should be saying 1. So really I have 2 times 1 minus 4 times 1. Well, what's 4? Negative 4 times 1, I'm sorry. Negative 4 times 1 is negative 4. So now I'm sitting at 2 minus 4, which is negative 2. Minus 2 again, it's negative 4. So now I'm ready to come in with my final answer. I had an x value of 1, I had a y value of negative 4, and I have got my vertex. Not too bad, okay? Pretty simple, and you can see that obviously number 2 went much quicker. So we should be pretty good. Let's take a look at 3 and 4. And what I really want you to do is I want you to do 3 and 4 on your own, okay? The one thing I want to point out, right there, that negative. When you go back to plug the x value in that you get when you work out number 3 in the vertex formula, is that you should not have that negative inside of a set of parentheses. That negative is part of the equation itself. Nothing that's part of the equation goes in parentheses. The only thing that goes in parentheses is the actual x value. So be careful with that. Go ahead, and I want you to pause the video, and I want you to work out these problems for yourself, and I will put up the answers. So when you're ready, you can hit play again. You can check your answers and see if you're right. All right. So your answers hopefully should match mine, 9,6, 2,2. If not, go back to your work and see if you can figure out what went wrong. If you can't see it, ask your shoulder buddy or ask somebody who did get these answers and see if you can figure out what happened. Don't just sit there and say, oh, I got the wrong answer, whatever. Find the mistake, and that's going to help you not make the mistake again. So we're done with the notes. What we're going to get into now is we're going to talk about the assignment that is equal to the notes. The assignment is not being turned in today, okay? But understand that it is going to help you work with an assignment that, I'll tell you what, you have time to do this assignment. I'm looking at my video. We're almost at 30 minutes. We'll be a little bit over 30 minutes by the time we're done. So you are going to go ahead. You're going to do this assignment. I'm doing the front with you because it shouldn't be too hard. And then you're going to do the back as an assignment by yourself. And that's what you're going to turn into the sub for your grade today. Okay? So make sure that you're paying attention. If you need to go back and do the video again so that you really understand what's going on with this assignment, that would be a pretty good idea, I would think. All right, I've had to kind of move the screen around a little bit so you can't see the numbers or anything like that, but I wanted to be able to get the whole thing on the screen so we could really look on this together. And we're just going to go through each problem, and we're going to basically draw a roller coaster and have a little bit of interesting things with it. So the first thing I want to do, though, is I want to identify the two problems that are happening here. Here is one. Okay, so that's a parabola that goes down, obviously. And then here is the second one, because throughout this assignment, it refers to two different parabolas. One with a of greater than 0 and one with a of less than 0, meaning one set of positive a and one set of negative a. Um, so just so we're on the same track, here are two parabolas. I'm going to erase these though, but you might want to leave it on your page. Identify the parabola with a maximum value. Draw a roller coaster car with 4 passengers at the maximum. So I need to see which one's got a maximum, which one's got a minimum. Maximum, by definition, means the highest point. So if I'm looking at the highest point, there's no way that can be it. This one goes down. It's the lowest point. So my maximum has to come with this parabola that's off to the right side. I need to draw a roller coaster car with 4 passengers at the maximum. 1, 2, 3, 4. There's a wheel. There's a wheel. And we'll just put a stripe on it for fun times. Okay. Next thing, identify the parabola with the minimum value and draw a roller coaster with 2 passengers minimum. Well, guys, we just identified the maximum. The minimum's got to be the other one. Okay. But this one to the left does go down. Okay. It's a low point. So there's my roller coaster car and my 2 individuals, and we'll give it a green stripe instead of a red stripe. We're good so far. We've got a maximum, we've got a minimum. For both parabolas, okay, both of them, maximum and minimum one, draw a flag for where the axis of symmetry is on the roller coaster. Well, think back to a couple slides ago. Okay. The axis of symmetry was a line that went directly through the vertex, and it was a vertical line. So what I'm going to do is I'm going to come through here. My vertex would be my actual maximum, my actual minimum. So what I'm going to do is I'm going to put a big circle just to kind of show you where I'm doing this. Here is the minimum of this parabola. So I'm going to come in at my minimum, and I am going to put a flagpole. And let's just give it a nice blue flag. I also have to do this at my maximum. Okay, I had my minimum, now I gotta do it at my maximum. Well, let's say my maximum be somewhere right around here. And we'll give it a nice, pretty yellow flag. That was not good. Y'all, I'm a math teacher because I can't draw. Alright, flags and people, and we're happy and we're good, we're having a good time. Moving on. Now we are going to number 4. For the parabola that must have an equation with a positive a. Think back to what a positive a value meant. Positive a values, okay, here's a greater than 0, that's positive a. Look at what this equation looks like, or this graph looks like. It's an upward facing u, it has a minimum. So back to our page, which one would have a positive a value? Would be the one that has the minimum, the upward facing u. So it's going to be this one on the left. They want us to draw a bird in the sky over this parabola. Now, fifth period, has already done this, and I got a kick out of our birds. We had 2 different types of people. I am the first type of person. My bird's gonna have a beak, and it's gonna have some big wings, and it's gonna have some feet. Okay, there's my bird, and maybe he's got some feathers. So I'm that first type of person. Here's the second person. Yeah, whatever you want to do, guys, okay? You're about to make one that is completely you, that you're doing completely on your own. It's not given to you right off the bat. So, you know, we're gonna have some fun with it. Let's have some fun. For the parabolas that must have an equation with a negative a value, well, if we just found that the one that goes down has the positive a, the one that goes up has to have the negative a. They want us to draw a sun in the sky. And let's see if I have got maybe some more fun markers that would do a good sun. Okay, here's one. Here's the sun. We've got a nice sunny day at our amusement park. We're having a good time. And maybe we just want to give our son some sunglasses. And he's happy because people are having a good time. Okay, we've got our big sunshine man, and we are on to exercise problem 6 on yours, and we're almost finished. Yay! So let's look at problem 6 and what it's got for us. If the equation of one of these parabolas, either the one on the left or the one on the right, is y equals negative x squared plus 10x plus 100, find the vertex. You were just working on finding vertex on this page, so we've already got all of our steps. Go ahead, take a second, find the vertex, so pause the video, and then play it when you got the vertex. Your vertex should match the one that I have written on our board, 5, 125. If it doesn't, get with a buddy that did get that number, and let's see where you went wrong. Last problem. Write the vertex from number 6 on or near the roller coaster of the correct parabola. Well, in order to figure out whether this is the one left or the one on the right, I'm going to have to look back at the problem. If I look back at the problem, I notice that my leading coefficient is a negative number. My leading coefficient is a negative. It's going to have to be the parabola that's going down, okay? Because a normal parabola goes up. Once you throw that negative in there, it's a reflection, okay? It's a change, it's a transformation, so it's going to have to be the parabola that's going down. So we're going to say that it is going to be the one on the right. And it wants us to write that vertex, 5, 125, on or near the roller coaster car of the correct parabola. We just said it was going to be this one on the right. So I'm going to come in and write 5, 125. And we are complete with our beautiful summer spring breaking picture. Gives you a little bit of hope in some dreary weather or just sitting inside and looking at white walls. So keep in mind, spring break's coming up. Woo! We are done with this page. You now have the back of this sheet that is very similar to this. You're going to draw your own. It says it doesn't have to be a roller coaster, but it needs to be something that shows a parabola. Roller coaster probably is the easiest thing. But do your own. Now, we don't really want a whole lot of like turns and flips and this and the other. You can have those things as long as you have at least 2 parabolas, okay? Read the directions very carefully about what you need before you kind of go off. This is your assignment for the rest of the class. I want mine. I'm not sure if other teachers are using this. Obviously, you tell your kids what you want, but for my students, my second and third period, what I want from you is that this will be turned in at the end of class. It will be fantastically creative and colorful, and you have markers and crayons and colored pencils over in the blue crates on the side of the room. I want you to use those things and have fun with it. So I will see you guys in a couple of days. Let me know if you need anything more than what we've got. It's pretty much a review, so I'm not expecting to have a whole lot of problems. But you guys be good. Have a nice day, and I'll see you in a couple days.